So, according to my notes, okay, the last problem, right, we started evaluating limits on Wednesday, and the last limit we did was this one right here. X squared plus x minus 6 over x squared minus 5x plus 6. So let's look at the next one. Okay. Excuse me, we did that. That wasn't the last one we did. This was the last one we did, right? The limit of x squared minus 4 over x cubed plus 8 as x approaches minus 2, right? And remember, to expand, right, to factor x cubed plus 8, right, that's the difference of cubes. You got to have all those formulas at the top of page 1 memorized for the exam, right? There's no formula sheet, right? It's all coming from up here. And in memorizing those formulas, look for the patterns, right? That's what I do anyway, right? I look for the patterns. All right, so we're actually doing the last limit at the bottom of the page, okay? Is our next problem. And does anybody remember what the first step is in evaluating a limit? What's the first step? You plug it in. It's called direct substitution, right? So you plug this number here, right, what x is approaching. You plug this number in for x into the function, okay? And if that equals, once you plug 1 in for x, if that equals a real number, right, the value of the function is a real number, then that's the limit. So down below here, let's plug 1 in for x. And in the numerator, right, under the radical, 1 plus 3 is 2, or 1 plus 3 is 4, and square root of 4 is 2. So when we evaluate the numerator and denominator, we get 0 divided by 0. And 0 divided by 0 is undefined. You can never divide by 0 in mathematics. Division by 0 is undefined. But this limit might actually equal a real number. Okay. And so back on what page of our notes in check? 2 minus the square root. Back on page 2 of our notes, we rationalize the numerator, okay? And that's the key to evaluating this limit. Okay? And rationalizing the numerator, we multiply top and bottom by the conjugate of the numerator. Just to remind you. Right, the conjugate of 2 minus the square root is 2 plus the square root. And when we're not going to repeat all the algebra. But when we FOIL the numerator, right, this is the difference of squares, turns out to be different squares when you FOIL that. And when we did all this simplification, we ended up with minus 1 over 2 plus the square root of x plus 3. So again, you should have this math in your notes, right, from page 2. Bottom of page 2. So on the exam, if you're given this problem, okay, you would have to do the rationalize the numerator before you could evaluate the limit. Okay, there's 2 parts to it. And now we can do the direct substitution. Okay, put 1 in for x. When we do that, we have minus 1 over 2 plus the square root of 1 plus 3. So again, 1 plus 3 is 4. Square root of 4 is 2. And 2 plus 2 is 4. So, the value of the limit is equal to minus 1/4. Okay. So the closer x is to the number 1, the closer the value of the function is to minus 1/4. Okay. That's what the limit does. The closer the value of the function is to 1, excuse me, the closer the value of x is to 1, the closer the value of the function is to minus 1/4. Any questions on that, ladies and gentlemen? All right, top of page 6. So this rational expression, right, we also simplify. We did the simplification of that on page 2 of your notes as well. Well, again, right, first step in evaluating the limit is to put 0 in for h, right? And so down below here, I can put 0 in for h. In numerator, you got to do order of operations, right? 0 plus 1 is 1. 1 squared is 1. Minus 5 times 1 is minus 5. And then the 5 minus 5, which is 0. So we end up with 0 divided by 0 again. So to evaluate this limit, we got to simplify. Okay. And we did that on page 2. And when we simplified on page 2, we got minus 5 times h plus 2. So again, here I'm referring to what the work we did on page 2 of your notes. And so it'll be like this on the exam, right? First I'll give you an expression, you'll simplify it, right? You'll rationalize it, and then you'll find the limit. Okay? I break it up into 2 parts. Okay? I don't just give you this question. I tell you to simplify this first, as part A, and then part B is find the limit, and so you use the result from part A to find the limit in part B. Okay? All right. So now you can do the direct substitution. We have -5 times 0 plus 2, which is equal to -10. So the closer the variable h is to 0, the closer the value of this function is to -10. Even though this function is undefined at h equals 0. This function's undefined at h equals 0. Because when you put 0 in for h, you're dividing by 0. That's undefined. But for values of h close to 0, the value of the function is close to -10. Any questions on that? All right. And then lastly, we have finding the limit of a complex fraction. So again, this complex fraction, okay, we simplified that in your notes on page 3. So when you do the direct substitution, you put 3 in for x, you have 1/3 minus 1/3 over 3 minus 3. And then the main numerator, 1/3 minus 1/3 is 0. And then the main denominator, 3 minus 3 is 0. So we end up with 0 over 0, which is undefined. But the limit still may exist. So this function is undefined at x equals 3. But the function may get close. The value of the function may get close to some number as x gets close to 3. And so the first step is to simplify this rational expression. And we did that on page 3 of your notes. And when we did that on page 3 of your notes, we got -1 over 3x. This comes from page 3 of your notes, okay? Simplification of that complex fraction. And now you can do the direct substitution. You put 3 in for x. And you get the limit is equal to -1/9. This minus sign in the numerator, right, I can pull up in front of the fraction. So the closer the value of x is to 3, the closer the value of the function is to -1/9. That's the limit. All right. Any questions on that, ladies and gentlemen? So now you have everything you need to successfully complete the website home. And I know some of you already have it done. I was impressed when I went on there. I saw that some of you already have it